Hi guys, Mrs. Anderson here. We're going to pick up where we left off with ecosystems and talk a little bit more about characteristics of ecosystems. So first of all, you may remember that ecosystems consist of biotic and abiotic factors. So when I look at those words, a recap here, bio, root word meaning life, I'm looking at my living factors. So things like plants, animals, fungi, bacteria, right down to a little single-celled creature. Those are all my living factors. Now, on the opposite side, I have abiotic, which means without life. Those are my non-living factors. So things like water, sunlight, soil, air, temperature. You'll also hear things like acidity, pollution, pH levels. All those things are my abiotic factors because they are not living. Okay? When examining the diagram, at what level of organization do abiotic factors become included? So when I look over here, I see that my organism, just on the individual level, my sole organism, when I have many of them together, that's my population. How many of that organism do I have? And then I look down at community, and at this point, now I have multiple organisms in a community. Now keep in mind, they'll also have a population, but for representing that, we're not going to put all of those in there. But these are all my living factors thus far. When I come down to my ecosystem, here's where I start to see my abiotic factors. You'll notice that I see a rock and some water. So ecosystem is the first time we start to pull in those non-living factors to see how they influence the ecosystem and the biotic factors. And then my biome will be even larger and perhaps have more abiotic factors. And then of course my biosphere, that's going to include all of my abiotic factors. That's where things like talking about the health of the atmosphere come in, because if the atmosphere is suffering or there's a lot of CO2 in it or pollution, that's going to affect everything reverse. That's going to affect my biome, my ecosystem, eventually my communities, the population in those communities, and eventually it will affect me. It will affect the single organism. Okay, so I'm going to give you just a second, and why don't you see if just right off the bat you can list a couple biotic and abiotic factors using this photo. So there are a lot of biotic factors in this photo. Everything from this bass over here to my little goose to these really tiny things. There's probably single-cell creatures in this water. Beaver, my aquatic plants over here. I might even have some decomposers in the form of some worms. This awesome crawdad. Of course, grass. That's a biotic factor. And my herbivore over here. Those are all my biotic factors. I got a ton of them. Now let's shift and look at my abiotic factors. Well, I have water, of course, and I could even consider the pH level of the water or what's in the water if it's not living as a biotic factor. I can look over here in the distance and make an inference that this might be some farming land, maybe a city in the background, and so this might be runoff into the water, and it might include toxins or pollution or other minerals that are also abiotic factors. I can look at the temperature of my ecosystem here. I can take note to pollution in the sky or the air quality. And I could even come down and look at this dead log and ask myself, well, I know that used to be a biotic factor, but at this point, it might be contributing more to my abiotic factors. We certainly have some decomposers living in there as well. So ecosystems, they become quite dynamic. And if you're feeling good with these abiotic and biotic factors, awesome. Like that's right where you should be. So now let's look at more characteristics of an ecosystem. Okay, so my three basic components. I have plants, consumers, and decomposers, and abiotic elements. So even though I have broken those down into three things, what they also mean is those are my biotic and my abiotic factors. So an autotroph, that means auto, self, troph, feeding. So a self-feeding thing is a plant. You know, it takes energy from the sun, uses photosynthesis, and produces sugars. Now, my heterotroph, meaning other or different, and then my root word troph for feeding, these are things that cannot make their own food. They have to eat something else to get energy. So a consumer would be like a mouse eating some wheat or some grass. That mouse has to eat a plant to get its food. But I can also have consumers who eat other consumers. So I might have a fox that comes along and eats my mouse. And decomposers are things that eat things that were once living. So my fungi and a lot of bugs will be decomposers. They will eat dead things, old living things. They're often overlooked, but they're pretty essential to most ecosystems. And then down here, again, my abiotic factors, all my non-living things. Okay, I'm gonna take a moment for this next point right here. This is super important. Solar energy is the driving force for all ecosystems. Let me rephrase that. Energy from the sun is what is fundamental to start and sustain all ecosystems. Now, within that ecosystem, carbon is the energy currency. So carbon is the element required for life. So if you are a living being, you have carbon within you. A good amount of it too. So go on a journey with me here for a second. Pretend that I have a seed, and that seed has carbon in it. And hopefully it has a rich area to grow in. The abiotic factors are strong. Hopefully it has lots of nitrogen in the soil, some water, the atmosphere is good. And now I have my solar energy and it's awakening this seed. And so my carbon is starting to flourish. And so my plant is growing. Then, of course, using photosynthesis, it's an autotroph. So after my plant grows, now I have a consumer who can come along and consume that carbon. It can consume the energy that the plant got from the sun and take it as its own. So my plant is here, my mouse comes along and eats my plant and acquires that energy. Now I have another consumer that's going to come and eat my mouse. It's my fox. So my fox comes along and eats my mouse, and now my fox has acquired the energy that the mouse had and also the carbon. Something tragic happens to my fox and he dies. He's laying there as a dead fox, and now my decomposers move in and they break my fox down. They too take energy from my fox and carbon from my fox, and they also break the rest down. And so the carbon that started in my seed and went to my mouse and then my fox, after my fox died, it returned back to the earth. And in ecosystems, you will find this cycle repeating over and over. The cycle that the sun's energy powers the whole ecosystem. Because if I don't have plants, I can't have consumers. So if I don't have plants, I don't have an ecosystem. I'll just have abiotic factors. So the sun's energy is a cycle in ecosystems, and so is the passing along of carbon. And that's pretty important. That's an important thing to understand about ecosystems. There is a law in physics that says you cannot create or destroy energy. You can only change it, basically recycle it. And the same law exists for matter, for mass, things like carbon. You can't create it, you can't destroy it, you can just recycle it or change it. So the next point right here, pools, quantities, and fluxes, flows of materials and energy. So basically what I just said about carbon, that's also true for things like phosphorus, nitrogen, other elements, and the sun's energy, and it will travel in cycles. And you can have ecosystems that are rich in certain resources, or ecosystems that don't have certain resources, or ecosystems that get them because they're seasonal. Okay, ecosystems are bounded spatially, meaning they have perimeters, they have boundaries, and then it changes to another ecosystem. And the scale varies greatly. So I could be in the Sahara Desert looking at my ecosystem, which is giant, and looking at all the sand and all of my biotic and my abiotic factors, and that's a giant ecosystem. But then maybe within that ecosystem, I have a tiny ecosystem. I have an oasis, a place in the desert where all of a sudden I'm finding some water and I'm finding some plants. And that ecosystem, even though it's much smaller, its abiotic and biotic factors are going to differ in size and in parameter from my other ecosystem. Okay, and lastly, biomes are widespread areas, and they're similar to climates. They're not exactly the same, but they're very similar to climates. Okay. Whoop. So when I look at this picture here, this is what I just said in words, but in a picture. You can see that I have my abiotic factors here. I have elements straight off the periodic table of chemistry. I have carbon over here, essential to my ecosystem. And I have the sun, the driving force, which allows my plants to grow and my consumers to eat my plants. And then when my consumers die and my plants, decomposers will break both of them down and contribute that nutrients back to the ecosystem so that it can cycle again. All right, our last slide for today, but this one's super important. You have a quiz on it, so pay attention on this slide. This is Latin and Greek root words for biology. And it's important that you get familiar with these because we're going to use these scientific terms moving forward. So you can see how an autotroph literally means self-feeder. So something that can self-feed itself is a plant using photosynthesis to produce sugars. And then over here, my heterotrophs, if I look at this, I have the word feeder and other. It needs to feed on others to get its energy. So those are my animals, those are my consumers and my decomposers. And of course, hopefully you're familiar with biotic and abiotic by now. And let's see here. A couple things that I mentioned briefly, but you'll also want to know, are things like a carnivore, root word, carni, flesh, and vor, one who eats. So a carnivore is one who eats flesh. I could also have a herbivore, one who eats plants, or an omnivore, like a bear, one who eats both plants and flesh. So I do encourage you to pause this, to take a moment on this slide because you're going to see these in a quiz shortly, and just make sure that you are comfortable with these root words. Okay? Thanks, guys. If you have any questions, reach out to your science team, and we'll see you next time. Have a great day.